So I'm going to mangle some names. I'm going to introduce people. At the extreme on the back row, far away from me, that's Gabriel, or Gabby, you prefer Gabby, das Rios, who is working on modules and represents Microsoft. And then next to him is Richard Smith. Richard is the project editor for the standard and represents Google. Also representing Google is Chandler Carruth, who's working on reflections. He's the chair of the reflections group. Representing Qualcomm is Marshall Clow. Marshall is the current library working group chair. Michael Wong represents IBM and is the, you've got a number of hats? Can we call you the transactional memory and game dev chairs? How's that? Okay. At the extreme distance on the bottom row is Beeman Dawes, former library working group chair. And next to him is Herb Sutter, the convener of the committee and representing Microsoft. And next to him is Bjarne, who is representing Morgan Stanley, and of course is the creator of C++. And then Ville, Voutilanien, did I get it close? Voutilanien. Yes. Okay, excellent. All right, I got it on the second try. The evolution working group chair and representing Symbio, yeah. Right? And then Lawrence Crowl, who is the numerics study group chair. Did we get through that? Whew. All right, it's downhill from here. All right. So we have a microphone here. Gosh, that's set high. I guess only tall people are allowed to ask questions. Can we drop that a bit? Yeah, and so if you have a question, you can come down here, but I've got a couple of pump priming questions. So let's start with Michael and come back. How about that? Michael, this is the question I want to ask everybody. What is the number one misconception that people have that you talk to about what the committee really does? Because it's really just an excuse to go to Kona for a week every year, right? Is that right? Is that what it is? Tell. There's a mic right next to you there. Oh, you've got a mic. Okay, great.
You're absolutely right. That's the only reason we go to Kona. No, but just imagine going to a place with 4 walls, beautiful, beautiful beach and sunshine outside, and you're not allowed to see it.
Oh no!
That is actually what it is to go to Kona.
I, of course, don't believe that. However, I will say that that members of the committee that I talk to all universally hold to that. So you guys have a really good pact about not letting the secret out. It worked, guys. How about it, Marshall? What is the number one misconception that you hear?
Well, I wanted to follow on with Michael's comment. Is that the first meeting I attended was actually in Kona. Yes. And I got there, and the first morning I took a picture and sent it back to my boss and said, Neener, I'm in Hawaii and you're not. And it's a picture of a meeting room with no windows and 70 people sitting around tables with laptops. So yeah, we got a good pack going here. We're all going to say the same thing.
So what's the question?
The question is,
I'm so confused.
When you talk to people about the committee, what is the number one misconception they have? What is it that they think the committee does that it doesn't do, or what is it? What assumption do they make that's not true?
All of them.
We're going to be here a long time.
No. I just mean I think that it's really opaque, and so most people's assumptions aren't actually accurate.
Right.
I don't know of any particular one that stands out.
Okay, so we're going to talk about a lot of them tonight then. Okay.
Yeah, I would agree with what the others have been saying about it being seen as like a holiday or something. It's really not like that. It is very tiring work. We're working often more than 12, 14, 16 hours a day for 6 days in a row. It's mentally draining.
Well, I think that's the number one remark. Yeah, I remember when I went to Kona in 2003. I thought I was going on vacation, and then I arrived in this windowless room in this very nice hotel. It was almost in the sea, right? And then they cranked up the air conditioner. And we didn't see any of the beach except at night, but then, you know, it's that much you can see. Yeah, I think that's really it. And you know, last week we were telling my coworkers that we're going to Kona for Stoners meeting. Oh, Hawaii! And say, no, please, it's not vacation. Say, yeah. So,
okay, yeah. Beeman, are you ready to tell us the truth?
No, I think the C++ programmers have become a lot better educated than they used to be about what the committee does, and I think that the internet has been a great help. I think the committee has over the years changed their procedures a lot, and Herb has certainly led the way in that area in recent years in making us much more open as a committee, in publishing more documents and so forth and so on. We don't hold anything back anymore, do we? Not really. And I think if you want to talk about the general programming, C++ programming public, I want to say we get great support from the C++ community, and that's about it.
First, we don't meet in Kona every time. You could get that impression. It's usually once every 4 years, so that we managed to do that at Plum Hall. I would say the biggest misconception I see, having thought about it for a few minutes, is that people think that the Standards Committee is a design team, meaning that when a new version of the standard comes out, you do what you would do when designing a product. You say, okay, it's going to have this and this and this, and we make sure the end-to-end experience is complete and that this feature is complete. And Bjarne is the main reason why we approximate that sometimes. But what a committee really does is a lot of individuals saying, I want this narrow feature, I want this narrow feature, and the only things that make progress are things are features that people care about and make work on and put work into. And it's actually a huge job to try to make a whole out of those little individual ball bearings. It is not like a design team, it really is like a committee, but thanks to the way that Bjarne and Ville run Evolution and the other group chairs work, we try very hard to make those things fit together, but people will still ask, oh, well, if you have these two features, why don't you have this obvious third one? Nobody had time to work on a paper, sorry. We welcome your paper. And yes, it's incomplete, but it's what we could do.
There's a lot of misconceptions. I would say that looking at the web and the C++ community, first I would think that the majority of C++ programmers doesn't know that the committee exists. And the majority of the rest think it's a few people, obvious idiots, because they're not doing exactly what they're supposed to do and what is obvious and easy. And probably malicious and probably bribed by Google or Microsoft or somebody like that. It's really rather negative, but if you read the web, Reddit and things like that, you'll see I'm not that far off. Let me point out that this group here on the stage would not quite be enough to fill one of the about 6 parallel groups that goes on at a meeting. It is quite a few people. There's a lot of experience. People are well-meaning, though not always going in the same direction, and trying to organize 100 people and 200 people helping is really hard. But really, the idea of a small group of possibly malicious morons is the main superstition, and it's wrong.
Only on Reddit.
Try Hacker News and just see if /dot is still alive.
So, are you done yet? Okay, I'd say that the two major misconceptions that I see are that C++ is designed by committee, which is truly not the case. We approve the design, yes, but we don't actually do the design work. And I would say that the second misconception is that we are a isolated ivory tower that works disconnected from industry and reality. And I don't think that's the case either.
So the biggest misconception I see is that the committee has an agenda. Okay, the people with the agenda are out there. So the way things happen is somebody who has a problem and really, really wants it solved, somebody who's willing to spend months of effort to get it solved, comes to the committee and says, here's my idea, and is willing to step up, and when the committee says, no, this is wrong, no, that is wrong, repeat ad nauseum, and you're willing to sit there and say, okay, I fixed that, then that's what happens. That's the agenda. It's the people out there that have a real problem and bring it to the committee in their person and in their effort. That's what makes it happen.
Just one comment. I think a lot of the people on the committee has an agenda. It's not quite the same. I published mine. I definitely have one. And one of the things that's really hard is to avoid the design by committee things and going in all kinds of directions, that doesn't overlap, so that it's easy to get done and do all the easy things. We try to do the right thing.
But to follow up on that, with one notable exception, all of us have pretty much started out there and ended up here by having a problem we wanted solved.
How do you think I got it? The problem we wanted to solve was called C.
On a related note, it does make me think one general pattern I see, I wouldn't call it the biggest thing, but you remind me, Lawrence, of a pattern, is when people will sometimes send us over the transom. In the publishing industry, you get a manuscript unsolicited, they call it over the transom. It goes into the slush pile. They have words for this. And sometimes there's a gem in there, and there's a lot of non-gems. People get the idea that they can send us an idea over the transom and say, well, I think you should add this feature, or I think this feature should be extended in this way. Here's one example, go do it, and are surprised when nothing happens. But I told you what to do, it's obvious, and they think that a one-page description which does not begin to cover the design space, or say what the trade-offs are, or what the alternatives are, or what the cost of not doing it versus doing it is, how it limits and opens or closes doors to future evolution of C++. Well, no, this is simple. It fits on one page. Why don't you just do it? The committee is stupid. I've seen that a number of times, unfortunately, but fortunately most people aren't like that. Those who are tend to just disappear. But we really, really appreciate all the hard work that happens by the people who come to meetings, and some who've never been to a meeting but have been very influential because they've helped with the design discussions. They've done work to produce papers, to listen to feedback, refine them. They get what it takes to make a product, and we really appreciate it. Nothing would be happening without all of their volunteer effort.
So I thought of a misconception I'd like to point out. And that misconception is that there's some kind of magical, special property that allows people to sit up here and talk about the committee. And so you know, one thing that I think a lot of people get very confused by is they feel like they can't come and join the committee, they can't influence the committee, they can't actually have an impact on the committee. It seems very distant. It is not actually all that distant. I would encourage anyone out there to try and actually see if they can fill this empty chair we have up here. We clearly actually are missing at least one committee member from this stage, so, you know.
So, Chandler, my question is, how much does that pay?
Say again?
I said, how much does committee work pay? What is the pay rate for being on the committee?
A very large negative number.
Do you count?
I just got to ask, so you didn't used to be a committee member. When was your first meeting?
It's the same first meeting as mine.
I also started in Kona the last time we were in Kona.
I can say that, yeah, the remuneration, if it weren't for Google and Microsoft bribing me, I would be having a lot of trouble making ends meet.
I'll say that my first committee meeting is going to be Kona.
So, to be on the committee, you pay $1,280 a year for the pleasure of doing all the work. And there are people who come there on their own pay. A lot of people get their employer to pay, and quite often the employer consider it vacation. Few people work more than half as long on a normal day that they do at a committee meeting. But really, we do something good for the community, I think. And so if you like to join. It will take some time to get up to speed. There's a lot of papers. And I think I'll disagree with Beeman. We were actually very open. It was just that sort of the web wasn't there. All the papers were available, but you had to find somebody to mail you the paper in the early days. We tried very hard to be open. The meetings were always open. We take, when we are in a particular town, people can come from neighboring areas and listen in. And almost all of the committee papers back to 91 is on the web. And the reason I say almost is there is a couple we haven't gotten scanned yet out of many thousands.
Essentially, the C++ committee is a giant open source software project.
From before the word were invented.
From before the word was invented, and essentially our work product, rather than a computer programs or software, is a document, a specification document. And that's the way and it's not too different from a lot of other open source software projects.
That's actually really a question. Bjarne, can you tell us a little bit about what it is like we have this word votes in the committee. Who can vote in the committee when you're talking about discussions and so forth?
I'm confused. There's no standard for how you make standards, or rather they change it every 5 or 10 years. But when there's a meeting, we quickly split up in some number of separate groups, sort of 5 or 8 running in parallel. And then there's the study groups, which are less formal, and there's a dozen of those. So there's a lot of people around in little meeting rooms concentrating on something or other, like libraries, new libraries, core language features, concurrency, such. And in those meetings there are some votes, colloquially known as straw votes. And the different subgroups does them differently. In evolution, where I've spent most of my time, we usually have 5-way votes. Strongly in favor, neutral, against, and over my dead body. And basically we use those to create consensus. Consensus doesn't mean that everybody agrees, but we really are quite unhappy if we get less than a sort of 90% majority. Because if we win something by 51 to 49, we know we'll get the fight again, and if it goes through to the standard, people will create dialects. Anyway, once something passes through a committee, a subgroup, it takes several meetings usually. It then comes up to the committee as a whole, and hopefully by then we don't have to argue much because it's been socialized, it's been discussed. People trust or should trust the working groups to make decisions. We don't really want 100 people sitting around having a technical discussion. When that happens, we waste a lot of time and a lot of people get miserable. And yes, a good guess on the number of people actually at a meeting is about 100. And my guess is that the people that helps out in between meetings is about 200 or thereabouts. And I can be quite wrong about the number of people on the web because there's so many ways people take part on mailing lists, telephone meetings and such. That gives some kind of idea. And yes, we start discussing things over breakfast and tend to end up after midnight.
So Bjarne, if people are really interested, there's going to be a really good example of this because we are actually holding a committee meeting this week. I don't want to take too much time about this. I intend to talk about this tomorrow in the open session at 8 o'clock, right?
8:15.
8:15, thank you. But there is actually a committee meeting, an official committee meeting being held this week, Wednesday, SG14 meeting. And in Bjarne's process description, this is actually the first part, the beginning of the process. You will see how papers are going to be triaged, how there's going to be feedbacks, there's going to be votes. And we actually have 6 or 7 papers on our dockets. And along with that, we also will have general discussions on a number of favorite topics, such as, what to do, what are people's feeling about exceptions and RTTI and GPUs and coroutines and things like that. That's appropriate for this subgroup.
So I actually have a question about that.
Notice, by the way, they start at 8:15, and there will be 3 or 4 other things you want to do while it's going on. This is very typical for a standard speaker.
So I have a question maybe for Michael, but I guess for everybody about this. So there's a study group specifically for the game developers. How do I get a study group for my industry?
Good question. I've asked myself that too. And sometimes I'm surprised that it happened. But certainly certain amount of common interests, a reasonable critical mass, and favored by the gods, it comes out that a study group comes out. I think that's... I've managed to get 2 of them in, and so I think I have a reasonable track record of success. That's right. I was going to say.
It would actually help if you would tell us what that industry is.
Well, I was speaking hypothetically.
How about having another question from the audience?
I would love to have a question from the audience. Nobody, either they don't think they're tall enough, or they... Oh, here we go. Okay.
Hi. So I do a lot of work in a variety of languages, primarily C++, but also C, a few other languages. And my question is about language interoperability, both to and from C++. It feels like a lot of people tend not to use some very C++ heavy features. And by that I mean, it's things like templates, sometimes references, specifically because they are difficult to make work with other languages, whether that be, maybe like a Python or a Lua or just some other new language. And I don't know how perceived or real that is, but I know it's something that I've run into. What my question is do any of you think that there might be specific things that the C++ community could do, perhaps even the standards committee, to help along that process? And might that include some kind of standardization on binary interfaces?
So there are a number of things in the standard that have been added that actually improve the situation you're talking about, but don't quite go all the way. For instance, reference parameters are almost ideal for interfacing with Fortran. So you can imagine an extern quote, Fortran quote statement defining a function that uses reference parameters, and then it would match up exactly with a Fortran function and carry on. Okay, so the reference parameters are now there, but we don't have the extern Fortran part. And that's going to take somebody who really cares about that to come forward with a proposal that addresses the issues, and it's not just reference parameters, and there are other issues with linking to Fortran and so forth that need to be addressed and need to be exposed in the paper. And the same kind of approach you might apply to other languages. So for instance, it's not inconceivable that a Java class has the same representation or has a representation available to it in C++ that you could map fairly directly. But we need an actual paper that says, here is the mapping. When we say this, and there's a C++ declaration that looks like this, it maps to this thing. And for the most part, anything that can interoperate with C, can interoperate in a binary compatible way with C++. The difference is that if the language can't interoperate binary compatible with C, then things get a little iffier. But a paper explaining what the pitfalls are and where progress can be made would be very welcome.
So I would say that the challenge I see here is a mapping of types. C++ has a rich type system. Other languages also have rich type systems. They tend to have impedance mismatches. And now you have to bridge between, two type systems that have some impedance mismatch. And that causes pain. One good way, I think, to do that is to drop down to some lowest common denominator, right, where you can reach firm agreement. In almost every case, it turns out that C found that lowest common denominator because it's actually related to the machine. And C was closely related to the machine. And so it tends to be a good bridge to build from. But the more complex the language, I think the more complex this is going to be. You're going to end up with the product of the complexity of C++'s type system with that of the language you're targeting. And that sounds really scary to me. It could be done, but I'm not actually surprised that people kind of reduce to very basic components in order to build these kinds of bridges.
Yeah, for those of us who likes higher level abstractions in any language, this is a great pity. But doing anything else is difficult. A C++ committee can't sort of go and make a standard to a random language. It takes two to tango, and so whoever controls the other language has to be in on this, and we have to agree. And the C++ committee is huge and diverse inside itself, so this is a very hard thing to do. I think the only thing that will really work if somebody brings forward a binding to the higher level types. It is really a pity if you can only exchange C-style character arrays rather than strings, and arrays rather than vectors and such, and we are usually reduced to that. But I would like to see something higher, but it's not something that one committee can do. It takes at least two groups.
Did you have a question, Isabella?
So I have two questions. The first one's super quick, and that is there's been a lot of papers that have been submitted in the past 2 years, 3 years, and some of them never see follow-ups, but they don't seem to have been withdrawn at all. For example, N3761, which added a value at and type at meta function that would let you basically pass in an index and a parameter list or a parameter pack, and you would be able to get the type out of that without having to do any like std-get decl type stuff. Is there a process for like declaring that a paper has been withdrawn or has been like declined, or is it just it's just kind of stuck up in limbo and there's no way to like find out what happened to the author maybe?
So we have various kinds of issue lists tracking papers. If you want to look at the status of any language proposal, you want to look at the evolution issue list. It's on GitHub. What we could improve is how we provide feedback to paper authors outside the committee. But we actually do track every proposal, and sometimes it happens that, I mean, in the case of that particular proposal, for example, I think we have a superior approach that we have given the design guidance to go forward instead of that particular approach. But you would really need to look at the issue list to see what the status of a proposal is.
Okay. All right, and then the other question I had was,
The other thing to add to that, so look at the issues list to see the status, but there's no such thing as withdrawing. I mean, no proposal is accepted unless it's accepted. Anybody can write a paper and, thanks for sharing. It's just a paper. It has no effect on the standard unless the committee considers it, probably revises it, adopts it. So unless it's adopted, there's no procedure for withdrawing it because there's nothing to withdraw. If the person just gives up and goes away, that's withdrawn. otherwise take a look at the active issues list for specific proposals where people are still actively working on them. But just because there's a paper doesn't mean anything. It just means that somebody once began to propose a feature. The only thing that matters is what's actually accepted.
Okay. Well, although
I have a
so sometimes we actually give negative guidance towards a paper, and I put those papers on the closed issue list as not a defect status.
Not about procedure, but a question I asked to people who suggest things, either to the committee or to me. That is, why do you think this is among the top 20 things we can get done in the next couple of years? Because we get, over sort of a 3-year period going to the next thing, we probably get 100 suggestions of what we can do. And I call them suggestions because they're just as this would be neat with one example, as I think Herb said, there's a lot of work. I mean, there's a lot of work just to get it to the point where we agree we want it, and then there's far more work to integrate it with the rest of the language. And so, is it on the top 20, and why?
Well, I can give you additional statistics. We get something like 45 papers for evolution alone for every meeting. And that's not counting the library proposals that we get, or the core language defect fix papers.
45 times 9 for a release cycle, plus libraries.
Okay.
We have to do something. We can't take everything, even if we wanted to.
Although probably 2/3 of those are revisions of older papers, so it's not all new material.
And so the other question I had was, with the release of Visual Studio 2015, the 3 major compilers, Clang, GCC, and MSVC, now support restrict on references. And has that been thought of being brought into the language proper and being standardized? Because they all do it differently, and it's extremely frustrating.
Yes and no. I actually put in a proposal to support restrict like semantics for future C++. That is still working its way. This is a good example of what it takes, right? We analyzed existing practice, found that it was wanting in various areas. It was designed primarily for C. Therefore, for C++, we got to do something better, more comprehensive. And along the way, you got to make sure that it handles lambdas, all the new things that are coming along. So you get the picture, and that's why it's taking a long time. So yes, we're working on it. At the end of the day, it might look substantially different, and it already is, actually. We have a paper in flight for some of that. Okay. So I think I wanted to, thinking deeply more about your question, your first question, you are actually asking kind of, if I am correct, is it possible to see the particular progress and stages of various papers? And as people said, nothing gets withdrawn. And in fact, some papers get revived after sometimes 10 years. But you're probably right. Along the way, some papers, because the wiki isn't clearly open to everyone, you don't know if a paper is in what state. Is it getting through, not getting through? I have no good answer to that. Right now, the wiki is not accessible to everyone, but many committee members report on blogs about what's going on, what was done that week, including papers that have been processed in some way. So I think right now it's much more open than before, given the fact that there are copious blogs talking about what's been processed and what's been heard.
Okay. Right.
Well, when it comes to restrict like semantics, that paper is actually through evolution, and it's supposed to go to core.
I know.
Yes.
Yeah.
So just to answer his question, yes, it's coming, and it's pretty far along in the process as well.
Yeah, we have a really good proposal by Mike and IBM that takes care of much more than restrict and is well defined. Restrict has a long and checkered history. It started out as no alias. Dennis Ritchie in person killed it with a famous paper, "No alias must go. This is non-negotiable." And it came up twice again in the C++ committee, and basically it cannot be defined precisely enough for people to be happy. Yes, you can use it with great effect on specific cases, but it's not as general, and there's traps people don't think about, and now we have a better solution.
I have a question about how the committee views, or what have you heard from the embedded C++ world? And of particular interest, do you view it as a dead dialect, language subset, or what have you? And this is of interest as we go forward, as we focus more on library development rather than new core language features. Because more and more there are going to be libraries, I fear, that require features that are no longer or are not available in embedded C++. And this is cross-cutting across study groups. So how does the committee view embedded C++?
I guess I can answer some of that. My position is fairly clear. Embedded C++ is a dialect that should never have been brought into existence. It was just a cut through the language at one particular point in time, basically pushed by people who couldn't implement a whole compiler in the time scale necessary. I'm very interested in embedded uses of C++, and we have people who talk about it. We have, I think, a study group that's related to it. Certainly there are people talking about it. I would like to see more support for embedded systems, systems where you have low amounts of memory, systems where you can't use FreeStore and such. There hasn't been as much as I would have liked to see there, but just subsetting the language and adding a non-compliant library or something like that is a very poor solution. Embedded systems is everything from people with 2K of memory to people with gigabytes but hard real-time constraints. So there is significant experience in embedded systems in the committee, but it doesn't seem to have as good traction as I would like to see it have.
There's recent renewed interest in having better support for embedded systems in C++. We have certain people who have been participating in committee work who have come back who are domain experts in embedded systems. It wouldn't hurt to have more of those domain experts participate committee meetings.
As far as libraries go, we support the entire C++ language, and that's the only language we deal with. We do categorize each header file as being required for all implementations, so-called hosted implementations. And then hosted implementations are ones essentially with disks on them. And we do make that distinction, and we get it wrong. It's harder than you think to make that distinction, and we get it wrong, and that's something that the community can help us with. They have helped us in the past. The BSI, the British Standards Group, that's one of the areas they've often made some good contributions by letting us know that we got it wrong as we categorized a component as hosted or non-hosted. So, any help in that area is certainly welcome.
One thing in general, and you'll hear Bjarne say this, maybe I'll say it so you don't have to be on record with the words, but the way to kill something is to fork it. And you can think about many examples, not just in our industry. And that doesn't mean that all forking and dialects are evil. Some are quite helpful, some are just necessary, and they just turn off a couple of things because they have to, and they just can't get around it, but they try to hew to the rest of it. But just arbitrary subsetting is not useful, and it's a good way to actually fragment a community. Pick Linux, pick anything. There's so many examples of this. Now, going back to Bjarne's keynote this morning, he used the word subset a lot. You will hear it again tomorrow a lot. There is a big difference. It is not declaring a subset where certain things are not available anymore. It's they're not available by default. You can still get at them. It is not creating a dialect. And that is a very subtle distinction that many media pundits wouldn't get. So I have no idea what the coverage is going to be, but that many would not get. They say, oh, Bjarne is advocating a dialect. Absolutely not. There's a difference between just turning something off, parts off by default, so you have to intentionally ask for them. That's different from creating a dialect. Creating a dialect and subsetting and saying, no, I'm just going to ignore those parts of the language forever and go off on my own road isn't generally helpful.
In particular, if you start building library without those features. But yet there is one library I would like to see for the embedded systems community. The part of it that I know a little bit about. And it is, I would like to see a set of container classes that does not use the free store. It can be done, it has been done. I don't see any reason why the committee couldn't support it. If not, I will see if the guidelines could have an embedded set of rules, because we would still be in C++ and we could get that library.
So there was about a decade ago, there was the performance technical report, which came out, which kind of shows the general trend of what the committee would prefer, which is it was a report on how you write code that has high performance, particularly in embedded spaces, and then advice to implementers of C++ and libraries of how you write them to also have good performance. So it didn't change the language at all. What it did is change the education of people both providing facilities and using facilities so that together they could produce the results people wanted without having to do surgery to the language.
And just to add to that, so that was brought up in C++ 98, 2003. What we didn't have time to do for C++ 11 is to go back and revise the technical report for the performance area. It is something that I would like, proposal from the community. We need to do that to educate folks about lambdas. People still say lambdas cost a lot, but really, no. We have the Constexpert was designed when I did this work with Bjarne. It was explicitly with embedded systems in mind. So we do care a lot about embedded systems. It's just that there's so much one or two individuals can do, and we need a lot of help and initiative from the community.
So I have a comment about that library that Bjarne referred to. There's some ongoing work about exploring those areas. The mistake that embedded systems programmers often make is that they think that they can just use a normal vector and have it have magically these dual semantics of supporting exceptions and working in the absence of exceptions. However, as I mentioned, there's some recent forthcoming work about supporting some sort of containers without requiring heap allocations or exceptions. So if all goes well and I'm not too busy during the remainder of the week, I may be able to write an initial draft, a quick stab at it, so that we can have something in the code and meeting about it.
This is another example of where nothing happens until someone's willing to do work. Thank you, Ville. Go ahead.
Well, I'm not willing to do work, but since nobody else seems to be doing that work, I might just as well.
You're Villeing to do work.
Let's hear more questions.
So speaking of agendas and not necessarily doing work, static initialization order fiasco. Why is it still a thing? This is Gorilla Committee, right? Why is it still a thing? Can modules fix it? This is, and I've only partially betrayed my agenda. Okay.
So I want to answer one thing first. If you have this problem, the sanitizers have a mode which catches it. It's super awesome. The second thing is, of course, modules will fix this. Modules will fix everything. Right, Gabby?
You stole my line.
So you go to Gabby's talk and you will get the answer. It's actually quite a hard problem, especially if you have dynamic linking and things like that. We've tried to solve it a few times and basically decided we couldn't, and that too many global variables with complicated initialization semantics is really bad for you, and it's getting worse with concurrency.
Yeah, and just to add to that, we did some work in that area. Now, with C+11, we got with this notion of literal types, which allow you to declare global variables and be guaranteed that you're going to have static initialization the way you expect from C, right? But in general, it is a hard problem. And yes, modules will solve just about any problem.
All right, do we have another question?
All right, I'm kind of excited. The proposal that you're saying you're going to write about these containers that don't use a free store, is that like intrusive containers, that sort of thing, or do you have something more in mind?
It's too early to say whether it will be intrusive and to what extent. The first thing we need is overall design guidance from the committee. There were some people who wanted to actually write the wording, the specification, and write a prototype implementation. I told them that we are at too early stages to go that far yet. So we need to solve certain design approach issues. So we need to write a overall description of what we are doing and why, and enumerate a couple of options and get the library evolution feedback of which approach should we take to go further with it.
So part of that question, there was a proposal some years ago about this library called EASTL, and one of the features of it was intrusive containers. I guess that's kind of why I mentioned it by name. Was that considered back then? Has that been looked at, or is that part of SG14?
It is. It actually is one of the motivation precursors to it. The original EASTL paper by Paul Pedriana was not looked at in 2007. I looked back through the history of it. It did contain a number of useful suggestions, many of which since then has been corrected by C++11. But part of the mandate of my group, SG14, is to take some of that suggestion. So to shortcut to the answer, intrusive container, yes, we're very interested in it. Okay. We're looking to gather momentum behind it. Come to the meeting. I'm going to add an agenda item on it on Wednesday to talk about intrusive containers.
Okay, sounds
Thank
good. I got one more quick question because that wasn't my main question. So is there going to be any overlap, or is it anticipated there's going to be overlap between the keynote today and I'm assuming the keynote tomorrow with the core guidelines, GSL, and the committee? Like, since you guys are on the committee, are we going to see some cross-pollination between the two? Is it hands-off, or?
So yes, our two talks are coordinated. So mine is kind of and you can see by the names, the names are interestingly similar, but they represent our work. We're also participants. Yes, we're looking at work like we hope everybody is. Like every company, Facebook and Google and all the other people who participate, individuals, if they want to propose something for standardization, will they work on it? They show that it worked. Then they'll have an eye towards standardization and creating proposals, doing the work of coming to the committee. And so we want to do that with that work as well. So we think that the array view and string view, for example, that are already going through the committee could be improved just a little bit more. If you tweak them just a little bit, you can get this benefit. So we're actually getting experience with them, and that will be proposed back to the committee. It is up to the committee whether they agree, or whether they partly agree and say, that's a good idea, but instead of doing that, why not this? So that's an iterative process. So yes, everything that we do, but we're participants. We want to have as something that we can contribute to the committee, but it's up to the committee to decide what they want to do, and that's a group consensus process that you have to go through.
So there's no conflict of interest or anything like that?
well, we're individuals too, so.
I got you. Okay.
I hope there's no conflicts of interest, and I don't see them. There is an overlap between what can be checked by a compiler and what is better done by tools. It's not humongous. And we will try to coordinate the GSL, as it's currently called, with the standard library. Hopefully they will be the same where both sides have interest. For instance, there's a set of concepts in the GSL which are borrowed from the plans for improvements of the standard library. So we're onto that one. There's other things where it is more style rules, more aiming at getting more maintainable code, which I don't think belongs in a compiler. There are things that when you check them, you'll get a large number of false positives. You don't want that in a compiler. There are things that cannot be done fast and locally. You don't want your compiler slowed down. So I think there are two different concerns, language design and guideline design. Furthermore, the guidelines will naturally fracture into things for different communities, just like there's different libraries for different communities. Not everything is one standard. So we have to have a different mindset. We mustn't think we are doing language design with the guidelines or trying to do everything with the language.
Thank you.
With the introduction of more powerful constexpr in C++14 and hopefully C++17 having concept slides, we've gotten a bit more powerful tools for compile time verification of things and computation. Do you see the language going more in the direction of more and more powerful compile time verification of conditions invariants, even arbitrary invariants? And was this one of the original aims of the concepts proposal or the concept of concepts initially, way back when?
You go first. Okay, I go first. Well, in general, the view is that when you write your program, there's a lot that you already express in your, syntactically in your program, and you really want the compiler to use those information at that information at compile time to generate the best efficient code it can and to guarantee safety. So that has always been the case all along. The version of context where we got in C+11 is the best we could given the circumstances, but it was also clear that we wanted something much better. And Richard here, was courageous enough where I failed to have that courage to face the community at large and to come and say, hey, we're already doing that. Let's remove these unnecessary restrictions. And I couldn't agree more. And I'm really thankful that he took on that task. And now, yes, we have better constexpr. We could even do more. Now, if you go back in 2003, today people say, why do I have to write constexpr when the compiler can just infer everything, right? And I see that question come up all the time as FAQ. Well, if you go back to 2003, that was already what we proposed. But again, the time was not right? You need this socialization of ideas and get tools up to speed, and we took the thing we could get, and then Richard came with, hey, we can do better, and he got it. Want to add something?
Yeah, I think there's more that we can and should and will do in this space. For instance, lambdas and constexpr interact very poorly right now. We should fix that, and I believe Ville has suggested he might work on a paper for that.
Really?
Sorry?
I wasn't paying attention.
Constexpr lambdas.
Yes. Good.
But we need to be mindful that there are costs to doing things at compile time. It's really valuable to catch all of the issues you can at compile time, to convert things to static storage when you can. That there are a lot of benefits to be had here, but compile time also matters, and so we've got to think about ways we can give these benefits which don't cause the compilation time to get significantly worse.
Yeah, I was going to say something very similar, which is that the more we do at compile time, the more we risk slowing down compilation, the more data about your program do you have to keep. Similarly, the back-end guys are getting better, but they take more time. I know that Gabby and Richard are working on modules that's going to give us a lot of compile speed, but we have to worry about cost of the stuff done at compile time. I really don't want a full program verifier as part of the compile chain.
You don't want a debugger?
I don't really think I want a debugger either. And also people want to have it predictable what it is that is being done at compile time or not. If you generalize and says, well, we can do everything at compile time and the compiler figures it out, I start getting very worried. We have to delineate very sharply what is done at compile time so that we can understand it without being language lawyers. And we have to make sure we don't slow the compilations down too much.
Yeah. I wanted to add one thing that we did, actually, concerning not just speed, but this time, but safety. Because the compiler has to evaluate your function with data you provide at compile time, we also have to ensure that it doesn't start doing stupid things. Meaning, we have to be careful about undefined behavior. So now I'm putting on my hat of chair of the study group on undefined and unspecified behavior. And one thing that we did, I think this is really a service to the entire community, is to say, hey, if we know this behavior is going to be undefined, then in well-specified context, then the compiler will actually diagnose that at compile time. And compared to previous version of C++ or C, I consider this as real improvement, based on feedback that user gave us, and I'm pretty sure in Clow you did very nice job at categorizing this. So you probably want to add something.
Just that. I mean, Gabby's right. Capturing the undefined behavior during compilation time is a very important part of context expert evaluation. But it was also, I would say, by far the most difficult part to implement. Because there's just so much of it, so many corner cases.
Sorry.
Now,
but it's the right thing.
Your initial question, we've been talking about const expert. You started your question with const expert and compile time, but then you segued near the end to use the word invariant. Now, some of that's compile time, but usually that means a runtime thing, and that's why I thought Gabby, who is also involved in this, was going to talk about contracts, which, interestingly, he has a talk about this week.
Yes, so I was also interested in how const expert would interact with arbitrary contracts verification.
Go to Gabby's talk. That's a long story.
Okay. Next question.
So I was basically going to bring that up, but contracts is sort of runtime matching of the code to your expectations. Concepts is also the compile time matching of the code to the contracts. So they're very similar concepts. Oh, bad choice of words, bad choice of words. Very similar ideas, just applied in different domains, and unfortunately they have different constraints because of the different environments, and concepts took a little while to show up. Contracts took a while to show up because in many cases the committee had bigger problems to address in the past. And now that some of those have been addressed, we can move on to some of these other things.
I think this is a good time to point out that gaining a consensus is a hard job. And just because we want X, it doesn't mean we're going to get it. When the first proposal for X comes up, I'm being diplomatic here, everybody loves it. X is motherhood and apple pie. And then we come to the sort of details. And everybody realizes that if you get the motherhood, you don't get the apple pie, and vice versa. And there's some cost, you can't get everything, and there's some cost involved, and there's aesthetic reasons. And sometimes it takes years to work out, sometimes decades. Sometimes it's easy, but many times it takes a long time. And very often there's some real reasons behind the preferences that means the consensus cannot be reached. And most of the time we work on and eventually we get something that's better. But it's not easy. You take something that's out there in the community, comes out of academia, come out of some industrial area, and try and generalize it to the whole world. It's a big world. It takes time.
Okay, are we ready for the next question?
I was just going to comment that there's also the issue of risk. That C++ is a production programming language. It is not an academic experiment. So with the first try at concepts, we got up to a point where we had something, it was in the standard, it was pretty good. I don't think there's any doubt about that. But there was a great deal of concern about risk there, that we hadn't gone far enough with it to be sure that the potential damage we would do if it was really, there was some real mistakes, was overcome by the benefits. There was a risk-benefit analysis, and we do that often, and that slows things down, and one of the reasons we're slow.
I'll give an example of the risk we are considering. At the very end, I wrote a paper saying there's 3 weaknesses in the sort of user interface to concepts. So I was worrying that it took too many heroics to compile it, and it was too hard to teach and use. The other set of worries had to do with compile time. People said, we will take concepts, it's wonderful, but it mustn't cost more than 20% addition of compile time. I thought that was very liberal. I would much rather see 5%, and that was a rule in the design effort that came after. And yes, concepts as we have them now in the technical specification runs as fast as anything that uses a little bit of template metaprogramming or faster. And so the risks are not just breakage, they have to do with implementation effort, with compile time cost, with runtime cost, with usability, teachability kind of stuff. We go through a lot of that kind of stuff.
Thank you.
To pick up on what you guys were previously just talking about, actually, some things are very trendy right now, modules, concepts, everybody wants them. There's this kind of video in the US that's taught to grade school children how a bill becomes a bill. When there's a really popular idea like modules or concepts that everybody seems to want, it still seems like it takes several years to get from that idea in a paper to an implementation. And is a lot of your work looking at the implementations described in the papers and then really picking apart those details and trying to get what you feel is the best implementation? Or is it more of a question of getting enough consensus? Or is there a lot of actual back and forth about how it actually goes from this idea to what are we doing?
So I can address that. I mean, the main problem is not the implementations. The main problem is that people mean different things when they come to the committee saying modules. And so everybody says, yes, I want modules. Everybody agrees. Everybody here wants modules. But you don't want the same modules, right? And so you come to the committee, and then you've got to figure out, when somebody says modules, what do they mean? And does that match what you mean? So for instance, back before C++ 11, lambdas were proposed. Everybody agrees there yeah, we want lambdas. Problem is, we had 2 major camps that each wanted different modules. And so the whole effort stalled for a couple of years until the committee as a whole managed to figure out a way to combine those 2 proposals into one mechanism so that both communities' needs were met. That mechanism, the C++ lambda mechanism, is more complicated than you see in most languages. But that's because it's solving more problems than the Lambda mechanisms in other languages are solving. And with modules, that will happen. With contract programming, that will happen. So the reason it takes that time is, first we have to work out what do people really mean. Then we have to work out what is a compromise that solves enough of everybody's problem to be useful, because we don't want to introduce 4 different kinds of modules. We only want to introduce one kind of module, but it has to solve enough real problems. And then once we get there, we have to write a specification that everybody agrees does that. That's why it takes the time.
Okay, I wanted to follow up on what Lawrence said, because I think there was a misconception in what you said. The product of the Standards Committee is not an implementation. The product of the Standards Committee is a specification, and then implementers go off and implement to that specification. And so it's not that picking apart an implementation, but making sure the specification expresses what the people who are designing the feature want, and that it is unambiguous enough so that the implementers can implement it, and that say a module's implementation in GCC and a module's implementation in Visual Studio and a module's implementation in LLVM or in Clang, they all work the same way, modulo bugs, okay? The same thing in the standard library, where a particular feature does not work different in 3 different standard libraries, because they all think, all the implementers think they're doing stuff according to the standard. So yeah, there's not so much picking apart implementations.
We don't standardize something because it's fashionable. By and large, it's by the time by the time we get to it, it's fashionable because we are doing it. So modules we've been looking at since about 2005. Lambda started in about 2002. We have looked at contracts repeatedly since the early things, some of the contracting. So it takes a long time to figure out what we want and why we want it, what are the limits to what we want. People always ask for implementation, and I think the main problem actually is design. Has these things been designed so that they actually serve the community well? And that takes time.
Can we get the next question?
So in the world that I live in, we really want vector iterators to be pointers. And I don't think this is uncommon. And if you look at, for example, array view, I think you can see a really clear motivating example for why you would want these iterators to be pointers. So my question is, firstly, does the committee have a preferred technique for converting a vector iterator to a pointer? Is this a problem worth solving, and if so, how should we solve it?
To answer the first question, dereference and take the address. Vector actually guarantees, with some horrible exceptions that you should never venture into, thank you, vector bool, that this works. And it gives you the address of an element, and it's contiguous, and you can treat it just like a pointer into an array.
Including end?
Yeah.
Okay.
It all works. Okay. This is fine.
He said including end.
Oh, including end, not
end.
end.
Yes.
No, you can't do this with end.
All right.
But don't. There are very easy ways to get around that.
Add size.
But end is easy. It's begin plus size.
Yeah. Yes.
Like,
data plus size. Data.
Yeah, we have data as well. There are lots of ways to get pointers out of vectors.
If you want a fully general way to do it, you can take data plus iterator minus begin.
And the range proposal is helping in that area.
All right.
So okay, Sean is bringing up that there's an abstraction penalty on vectors. And I just want to point out that on my particular implementation, we actually guarantee that vectors iterators are pointers. And our users rely on that, and we support them in that because it's a conforming and extension of the language.
Okay.
I've noticed that there is a tendency for certain high-level languages to accrete truly stupendous amounts of code in their standard libraries. And this is in sharp contrast to C++, which I attended the talk on the history of executors, and seem to be a lot more frugal here. So my question is basically, what generally seems to be the criteria by which the Standards Committee judges proposed standard library additions, and how do those vary from core language extensions?
I'll give just a context answer before we go to the details. The main reason is money.
Okay.
Other languages have owners that can spend a few dozen $1 million on getting a library. The C++, we have to pay to do the work, and it's quite often not our day job, and that's the real limiting factor. And now somebody else can start answering the real question.
You're going to put me on the spot after sitting up here quietly for so long. We have the standards, the library groups, the standards committee have a hard time with large proposals. They're hard to review. We have a couple, 3 in front of us right now, and we're struggling with them just because they're so large. We have a networking proposal, we have a ranges proposal. They're each a couple hundred pages. We know how to review small proposals, 5 pages, 10 pages, something like that, and we do okay with that, but that doesn't really scale to growing the standard library in large chunks. And we're working on getting better than that, but I don't have a magic bullet, just because there's a lot of interactions, and we want to make sure that when we define something that it comes out well, that we're not going back and changing the specification for years at a time. If you look at some of the other languages, I'm going to pick on Python momentarily. Not because because I hate Python, because Python is kind of my go-to language for small programs. But if you look, there's, I'm thinking of is it the URL lib? The URL parsing library. It's now URL lib 3, and URL lib 2 is just, don't use that. And we'd like to avoid that. I mean, we did that with auto pointer, and it haunts us for years because we can't get rid of it, although we are getting rid of it. So it's not something we do well, and we're trying to get better at it.
I think one thing to understand about the way the library works is that while we talk about policies occasionally, the library working group has never had a policy document. We've never agreed on anything much. So every in general. So how do things really happen? Every proposal is evaluated on its merits. So if somebody comes along with a proposal that people in the room really like, but just does things differently than what we have, if everybody likes it, that proposal gets accepted. If somebody comes, and that's only happened once, it was called the STL. We threw away several years of work, multiple years of work, more than 2 years, multiple years of work, because we considered that a work of genius. And we evaluated it on its merits. People have come forward with proposals that if you had a set of policies, they would have gone right in because they met the policies. But in the considered opinion of the library working group, the motivation was what will kill a library that is perfect in other ways but kills it right away is the motivation isn't strong enough to standardize it. And there's a bunch of things you look at, and is it widely useful? Is it something that people tend to get wrong when they do it themselves? That's a shared pointer was, I don't, it's, you have to never say never, but many of us have never seen an implementation of shared pointer before shared pointer came along and those specs came along that was correct. We could always find some bug or another. It's incredibly difficult to implement correctly, incredibly. And I mean, Scott Myers and all these people that are considered to be experts did it wrong. And that's a strong motivation. Something, on the other hand, that is trivial, one line of code, it's easy to get right. It's easy to understand. It's going to take some other motivation to make us be interested in that. So we evaluate each proposal on its merits, and that's, you come forward with a good proposal that the people in the room like, it'll go forward. And then that gets reviewed and reviewed and reviewed and reviewed. But there's no overall policy that if you read the policy, you can determine ahead of time whether a proposal is going to be accepted.
And in there lies a big problem, as Bjarne knows. It's really hard to set a direction for a diverse and changing group of 100 people with several hundred friends. And it is a problem to keep coherence in the core language. It's troublesome to reach coherence in the standard library. I mean, how do you report errors? What are the naming conventions? How are resources managed and such? It's very hard. And there is a tendency for little standalone proposals to work their way through, and big ones getting stuck, things that affect several libraries or several parts of the language getting stuck because they have major impact. And I think this is a constant problem and a constant tension, and I don't think we know how to resolve that in general.
Did we actually answer your question?
Yes, you did. Thank you.
Okay.
Can we have the next one?
Hi. I have two questions. The first is, I find myself referring to the standard draft pretty often, and I would find it very convenient if the document was an HTML document with hyperlinks and stuff, so I could create URLs and give them to friends and talk about this section and that subsection, or link them in bug reports. It would make my life a lot easier.
So I have it on good authority that you know where the project editor sits.
Yeah.
And you know what? I'd like that too.
Okay.
So it's definitely something I'm interested in pursuing. There are some questions about it being an ISO document, exactly what we can and can't do there that we need to answer before we go too far in this direction. But it's definitely something that would be useful for the committee and for the wider C++ audience.
Okay, great.
And also, the standard's on GitHub, so patches welcome.
Oh, okay. All right, I'll definitely look into that.
All right.
I had a...
Yeah, let me make one comment in that we're doing some experiments in that area. The technical specifications in the library, at least file system and fundamentals, and I'm not sure about any others, but were written and maintained in HTML. And in fact, the committee, just the file system one, it appears twice, once as a draft in HTML, and then as the actual final technical spec as a PDF document. And that's the same document. The PDF is driven off the HTML. So and the fact that those technical specifications appear to be successful, we're not getting complaints about their formatting, at least that I'm aware of anyhow.
Yes, this is very good, and you'll never believe how picky Geneva is, the ISO Secretariat. I think they think their lives depend on us doing the pagination and the fonts of the numbers and the page numbers correctly. They can delay us for months over details like that.
I thought it was that we were providing Word files to them.
Yes, and they might want Word files. They are really backwards.
Yes.
Yeah. So.
But the reason they want Word.
Yes.
But the reason they want Word files is so that they can edit them more easily, and that's one reason that I love that my answer every time they ask that is, "Oh, I'm sorry, we have no Word files. We maintain it in LaTeX or whatever," and then they usually ask, "Oh, okay, please send us the Word files." And I'll say, "Sorry, here's the PDF, we don't have Word files." And then they go away. And then they make fewer edits. That's nice.
So I've noticed while reading this, the C++ standard draft that it makes references to C and compatibility towards C, by, in its definition of how signal handlers should work and sig atomic T and whatnot. But I don't see very many pages or any sentences referring to its compatibility with prior versions of C++. And changes to the language are made between, from time to time. And
No, look more carefully.
Same place, Annex C.
Really?
Yeah, C.2 through C.4.
Okay. All right.
And here I thought you were going to comment that the C standard doesn't seem to say anything about compatibility with C.
Okay.
Well, it must be admitted that we don't actually always do a very good job at updating those annexes when we make incompatible changes.
All right. Because
what incompatible changes?
That seems like such a loaded question. I will refrain from answering that.
All right.
Okay.
Currently, we have random number generators such as uniform int distribution. So I was wondering if it's possible, or if the community is reviewing it, to have arbitrary bit generators, or like character generation or random string generation.
42.
Upcoming. Okay.
Oh, you wanted a different random number.
The real answer is random device, which you can get truly random numbers derived from cosmic background radiation if you have a supplier.
Are those still integer types, or could those also be character types or string?
I think that I'm not 100% sure off the top of my head, but I believe the random devices produces bytes. And then it's like generate canonical, which takes those bytes and turns them into integers or longs or whatever.
Is there a platform-specific way to convert it to characters, though, or white characters?
Yes, read the underlying storage. It is documented and specified to be characters. And if all of the bits are random and uniformly random, guess what the bits of the characters will be?
Not guaranteed sometimes if it's Unicode or so forth.
But the whole idea of
No.
random Unicode is kind of odd.
Random Unicode is not.
Yeah, so there's nothing like that that could it even be possible to have a generator?
But if you want characters, right, like bytes, you can get that.
But
if you want something more advanced, write a paper.
I think there's a proposal in the works by STL, but I don't know if it's been reviewed
Excellent.
or not.
If STL has a paper, it'll get reviewed.
Hi guys, you compared yourself to an open source project, but at the same time you said that it's quite high entry barrier on the financial aspect and on the time side. Personally, I contribute to KDE, a very big open source project, and there we have a non-profit organization which gives funding to students that could otherwise not attend developer sprints. So I would compare that to what you guys are doing, right? So is there any process in getting that?
Yes, as of this year. So go take a look on isocpp.org/about. Under policies, you'll find a financial assistance policy, which is for not just students or people who want to watch, but for people who have already started proposing. Now, having said that, the goal is not to make it free for everybody. There's a cost to going. In fact, when Bjarne said the $1,200 to join, to become a member of ANSI, that's the smallest cost. You'll spend more than that just on hotel and airfare getting to all the meetings. On your own dime. There's real effort involved, never mind the work between meetings, and much interaction needs to happen face to face. But for people whose employers are not able to fund them or not willing to fund them, or who may be self-employed, and who have already shown that they have a proposal, they've put their own work into, come to a meeting, the committee actually likes it, it's not some harebrained thing. There is now, and for the last several meetings has already been in effect, a means to get those people there. Now, that's not most participants. Most participants still have to self-fund. But we do have something like that just recently.
Also, I think it's worth pointing out that being a standard is a legal thing. The ISO is some sub-branch somewhere of the United Nations, and to get an ISO standard, you have to pay to do the work, and we can't change that. We have to follow some rules, we can't change that. But in return, we don't get hit by, say, the US cartel laws. If the people on this platform got together in private and decided what C++ should look like, we could and would be sued, and our companies would be sued. Furthermore, we could and would be stopped from talking to each other, because by and large, competitors can't talk. So we get that freedom out of the rules for standardization. What we do is a public service. If we didn't, it would be against the law. And it's tricky. And we didn't make up the rules. We do everything we can to make things open and accessible. But there are realities that we can't really deal with, such as national law and international law.
If I can pick on Google and Microsoft, just as an example, because we get all the slings and arrows. So if Google and Microsoft and friends had this kind of conversation on our own, it would be collusion. Because it's under ISO, it's consensus.
As I said, illegal versus public service.
So
that's what you pay. That's what we pay the $1,280 for.
So I want to thank you guys all for grilling our committee here, and thank the committee for putting up with this. What?
Wait, one more.
One more question. Okay.
I think you actually just were starting to touch on this. You mentioned not being sued and in earlier questions having to give out Word documents. I was just kind of curious what the best and worst parts of working with a huge group like ISO are.
This is all you, Herb.
The first thing that comes to mind is the best are when they leave us alone. But it's like any child. You want to get you want your parents to do everything you want them to do, and then not bother you and not worry about their rules. So part of my job is to shield the committee from ISO. That's an imperfect thing, and so just like a good manager or a vice president shields you from the executives above and lets you get your job done, but gives you enough direction and structure so you're doing something reasonable that is helping the company. There are some similarities there, and mostly ISO's rules and structure are there to help. Now, they've been refining their structure, which is good because it was glacial. Now it's, what's the next thing down from glacial, but still geologic? Now it's seasonal, so that's an improvement. But but we're still able to get a lot of things done ourselves. Every so often there's a hiccup like there was in the past year, and they say, no, you must put your documents in this place. And then we figure out, okay, how do we satisfy them? And then we found a way to do it. Most of our documents no longer have N numbers, so we don't have to put them there. So you will, for the first time, see documents that don't have the letter N in front of them. Most of them will have the letter P starting this week. And if you want to know why, it's mainly so we don't have to put them in an ISO repository. So you deal with stuff like this. So you deal with stuff like this once every few years, but in return you mostly get left alone. Your balloting system and mechanics are already in place for you and structure that help you get your work done. So it's learning to use the process and work within it, and that structure is helpful. Sometimes structure is liberating.
I would say for me, the worst part is when they tell us that we need to use the new cover sheet for our draft standards.
And you shield us from that, because I don't have to worry about that.
All right. Well, I want to thank everybody for being here and doing the grilling. I want to thank the committee for being grilled. Thank you all very much. And after one day of CppCon, I want to ask you, are you excited about the speakers you saw today? Are you happy about the content? Yeah. Then, thank you. Then I have an opportunity for you to repay that. You're going to be receiving a survey about, you're going to receive a survey every single day you're here. So you're going to receive Monday's survey. Please be thoughtful. Please take time. The speakers that you saw today put an awful lot of time into the material they presented, and if you would think about that and give them some thoughtful comments, they would all appreciate that very much. So thank you very much. That will help conferences in the future. So get a good night's sleep and be back here for a lot more excitement tomorrow. Thank you very much.